everyone. Welcome to the course Principles and Applications of Mechatronic Systems. In this lesson, we will enter Chapter 6, Design of Mechanical Transmission Systems. Today's topic is Overview of Mechanical Transmission Systems. This section covers the components of a mechanical transmission system, different types of transmission methods, and several key indicators to consider during the design process. I hope by the end of this chapter, you should have a clear understanding of the basic structure of mechanical transmission systems and master the core concepts in their design and application. Next, let's learn the components of a mechanical transmission system. On the screen, you can see the components of a typical machine. A machine usually consists of three parts: the prime mover, the transmission system, and the working machine. Let me introduce each part one by one. Please look at the first part, the prime mover. The prime mover refers to a device that converts other forms of energy into mechanical energy. In the diagram, we can see electric motors, gasoline engines, and steam turbines, which are all common prime movers. The main function of the prime mover is to provide the power source for the mechanical system. Next, the second part, the transmission system. The role of the transmission system is to transmit the motion and power of the prime mover to the working machine. It serves as the intermediate bridge of the entire mechanical system. Here, several common transmission types are shown, such as gear transmission and belt transmission. We will study these transmission methods in detail later. Finally, look at the working machine part. The working machine is the device that directly performs the production task. In the diagram, we can see examples such as a lathe, a rice milling machine, and a water pump. The working machine ultimately relies on the power provided by the prime mover through the transmission system to perform various specific tasks. Next, let us define these components in detail. The prime mover, as shown in the diagram, is a device that converts other forms of energy into mechanical energy. Common prime movers include electric motors, gasoline engines, and steam turbines. They provide power to the system through different energy conversion methods. The transmission system refers to the device that transmits the motion and power of the prime mover to the working machine. It acts as the link between the prime mover and the working machine. According to the medium used and the characteristics of transmission, the transmission system can be divided into mechanical transmission, hydraulic transmission, pneumatic transmission, and electric transmission. The working machine is the executing device that directly completes the specific production task. For example, the lathe is used for machining parts, the rice milling machine is used for processing rice, and the water pump is used for conveying liquids. Please pay attention to the arrows in the picture, which indicate the path of energy and motion transfer. The power generated by the prime mover is transmitted through the transmission system and finally delivered to the working machine to accomplish the intended production task. Next, let us look at the different transmission methods in mechanical transmission systems. Each method has its own characteristics, and the appropriate transmission method can be selected according to specific requirements. The first is screw transmission. As shown in the figure, screw transmission transmits power through the meshing of threads. It is suitable for scenarios that require high torque or high precision. The second is gear transmission. Gear transmission is a very common transmission method. It transmits motion and power through the meshing of gears. The characteristics of gear transmission are high efficiency and the ability to accurately control speed and torque. In the diagram, we can see two sets of gears engaged with each other. The third is belt transmission. Belt transmission uses a belt to transmit power. Its characteristics are simple structure, low cost, and suitability for long-distance power transmission. In the diagram, a belt pulley system is shown. Its flexibility gives belt transmission certain advantages in some applications. The screw transmission diagram shows the precise engagement of threads, The gear transmission diagram emphasizes the meshing of gears, and the belt transmission diagram highlights the flexibility of the belt. The design of a mechanical transmission system is very important. In order to ensure the accuracy and stability of the system during operation, we must pay attention to the following key indicators. First, transmission accuracy. Transmission accuracy directly affects whether the system can accurately transmit torque and speed. This is particularly important in precision machining scenarios. Second, response speed. Response speed refers to how quickly the system can respond to changes in the input signal. For some working environments with frequent dynamic changes, a fast response speed can ensure smooth system operation. Finally, stability. Stability refers to whether the system can maintain reliability during long-term operation, especially under complex working conditions and high-load situations. Ensuring the stability of the system is very critical. Today's lesson ends here. I hope that through today's study, you have gained a deeper understanding of mechanical transmission systems. Thank you for listening, and see you in the next class.